I'm Anil Kumar. Welcome to my series on rate of change. Here is another thinking and communication question. The question here is, the given point is either a maximum or a minimum on the function. Verify using rate of change and explain your solution. So this is part B, where the point is B minus 2, 8 on the function f of x equals to 2x cubed plus 6x squared. So in this case, we will check the rate of change around the point minus 2. So let's find the value of the function at minus 2 first. So that gives you 2 times minus 2 cubed plus 6 times minus 2 squared. We need to find rate of change, preceding and following rate of change. So let's take the value. On the left side of this, a point will be minus 2.1, right? So for that, the value will be 2 times minus 2.1 whole cube plus 6 times minus 2.1 whole square. We'll use calculator to figure out these values. And on the right side, it will be minus 1.9. So at that point, the value will be, we'll substitute minus 1.9 in the function to get this value, correct? Now let's use the calculator to find all the values. So first is 2, within brackets we have minus 2 whole cube plus 6 times minus 2 within brackets, right? Square. So the first value here is 8. Now we'll change 2 to minus 2.1. And then again calculate. The value here is in decimals is equal to 7.938. The next value here will be checked at minus 1.9. And this is equal to, in decimals, 7.942. So basically from the values also you get an idea that on the left side it is lesser than 8, right? So it is kind of like this. So what we found is that at minus 2, the value is 8. At minus 2.1, this is when x equals to minus 2. Then let us say this is 2.1. So at this point, we have minus 2.1. The value is 7.9, let's say 4. And on that side, we have at minus 1.9, you can see the value, which is 7.94, correct? So looking at this diagram itself and from the points themselves, you do see that if I join or if I draw a line here, we get a positive slope here. On this side, we get a negative slope. In between seems to be 0, correct? So that becomes a maximum. Do you understand the concept, correct? But we'll actually find the preceding and following rate of change, right? So let's calculate preceding average rate of change, right? So in that case, we are going to use the value f of, so this is minus 2.1, right? Minus 2.1 minus f of 2 over minus 2 minus 2.1 minus 2, correct? So minus 2.1, the value was 7.938. Take away the value 8, and in the denominator we get minus 0.1, right? That becomes plus minus. Let's calculate this. So we have 7.938 minus 8, and then we'll divide this by, let's say equal to first, right? I didn't put bracket, so I'll divide by negative 0.1. So that gives you approximately 0.62. Is positive, correct? Now let's find the following. Average rate of change, right? So in that case, we are going to use these two values, which is f of minus 1.9 minus f of minus 2 over minus 1.9 minus 2, correct? So these values are 7.942 minus 8 over. So when you do this, that is 2 minus this, which is plus 0.1, correct? So we get 7.942 minus 8 equals 2 divided by 0.1 equals 2. So in decimals, this value is minus 0.58. Correct? So slope on this side, rate of change is minus, right? So basically at 2, so what is the instantaneous rate of change when x is equals to minus 2? It is average of these two, right? So we'll just add them up, 0.62 plus minus 0.58 divided by 2, right? So which you get, so 0.62 minus 0.58, and then we're dividing this by 2, so the decimal value is 0.02, which is approximately equal to 0, correct? That means it's a horizontal tangent at this place, correct? Now you can clearly see that in this case we have a positive slope, right? So it is a positive slope on the preceding side, negative slope on this side. So at 2 we have a maximum, right? So we have maximum at minus 2, right? So at x equals to minus 2, since slope of tangent, slope changes from positive to negative. Is that clear to you, right? So that is how we can confirm using rate of change. So the concept is rate of change. That at the given point, we have a maximum. At the given point, the instantaneous rate of change is 0. That means a horizontal tangent line. So it has to be a maximum or a minimum, right? So we have a local maximum. I should write this as local maximum for sure. Is that okay? So that is how we are going to do it. So I hope with this you understand how to solve questions based on rate of change. We took actually very good examples, and they will really help you to understand all the concepts. So these were the 3 examples. The last question we just did was this one. I will like you to practice once again, solve such questions so that you're absolutely ready for your Unit 2 test. Thanks for your time and all the best.